Welcome. Let us see a problem on projectile motion. Now, a particle is projected with a velocity of 45 meters per second at an angle of 30 degree with respect to the horizontal. Now, let us see how the particle travels in space, and let this be in the horizontal coordinate system. The particle is projected with a velocity of 45 meters per second, that is, its initial velocity is described in the question, with an angle of 30 degree. Now, the particle takes the path like this, and it reaches the other side. While it is so, the path traced by the particle is given here, displayed in blue color. Now let us move on to the question. The first question is the time taken by the particle to reach the maximum height. This one will be the maximum height. Now they are asking what is the time taken to reach from this point to this point. Now let us move on to the next question. The total time taken by the particle for its travel. That is the time taken by the particle to begin from this place, and when it reaches here, what will be the time, the total time from here to here. Now so we have 2t. By summing up those two times, we will get the total time. Now the third one is maximum height. That is, in y coordinate system, the height reached by the particle, the maximum height reached by the particle. Next, the fourth one is the horizontal range. That is, the horizontal distance covered by the particle, that is horizontal range. And the fifth question, during the solution procedure, let us see that. Right now we will skip that question. Before getting into the solution procedure, we should know the formulas related to the projectile motion. In one of our video, we have derived the formulas for projectile motion. You can refer that. But anyhow, one should be familiar about all these formulas in order to solve the problem in projectile motion. And let us move on to the solution procedure. Before that, I have arranged all these formulas in the right hand side so that we can refer it then and there. The first question is time taken by the particle to reach the maximum height. That is, in order to reach the maximum height, what is the time taken by the particle? We have the given data, that is initial velocity from the question, similarly the angle of projection here, and the time taken formula is given here. Let us utilize that, and the given data, initial velocity and angle, are given here. I am utilizing that, and finally we get the time is 2.29 seconds. That is, the particle takes 2.29 seconds to begin from here to reach here. And the next question is the total time taken by the particle for its travel. It is the time taken by the particle to reach from this position to the highest point, next from the highest point to this point. So by adding up these two times, we get the total time taken. That is, when we multiply the first formula by 2, we get this formula, or either you can use it directly. I am using the second one, and the initial velocity and the angle is given here. Taking those two given data into consideration, we get the total time as 4.58 seconds. The third question is all about the maximum height. So according to the figure, let us define this one to be the maximum height, and the third formula defines the maximum height, and I am considering that formula for the solution. As the given data are given here, I am utilizing the initial velocity and angle of projection, and the maximum height is calculated. 25.80 meter is the answer. And the fourth question is all about the horizontal range covered by the particle. For horizontal range, we have the formula u square sine 2 theta by g. I am utilizing that formula to calculate the horizontal range. So taking the initial velocity and angle of projection into consideration, we find 178.76 meters as a horizontal range. And let's move on to the fifth question. For the given velocity means the initial velocity is defined as 45 meters per second. For that velocity, what is the angle needed to cover the maximum horizontal distance? In previous question, we have found the horizontal distance. But now, what is the question is, if the angle is changed, what will be the maximum distance covered? Okay, possibility is given to us in order to utilize different angle so that you find out what will be the maximum distance covered. And let us use the fourth formula again. But before going into that, let us have a simple analysis. So this initial velocity is fixed and the acceleration of gravity cannot be changed here. The only possibility available here is 2 theta. That is, significantly we can change the theta. So sin 0 is 0, sin 30 is 1 by 2, sin 45 is 1 by 2, sin 60 is root 3 by 2, and sin 90 degree is 1. So the 0 increases to 1, and that 1 value is for sin 90 degree. So if we replace this sin 2 theta by 1, we get the maximum. Whenever we use the angle below 90 degree, the value is below 1 or lesser than 1. So in order to have the maximum horizontal distance, we have to substitute the 1 here. If we substitute any other angle means we won't get the maximum distance. Hence, let us substitute 1 in place of sin 2 theta. That is, sin 90 degree is equal to 1. Of course, this 90 degree is nothing but, according to this formula, 2 theta is equal to 90 degree. And of course, theta is equal to 45. When we take this 2 to the denominator of 90 degree, we get theta equal to 45. Either we can substitute theta equal to 45, or directly, instead of sin 2 theta, let us substitute 1. And getting the initial velocity here, we get the maximum horizontal range to be 206.42 meters. And finally, the answers are like this. And let us compare the fourth one and fifth one. When the angle is 30 degree, the horizontal range is 178.76 meters. Whereas when we change the angle in such a way that in order to cover the maximum distance, that is, accordingly we have found theta equal to 45 degree for maximum horizontal distance, we get the value 206, which is higher than the distance which is given by the angle 30 degree. Okay, with this we end this video.